This is the 5th lesson of the Next Generation Security Management Training. In this lesson, we're going to talk about the threat prevention policy. In this lesson, we're going to cover how STP maps into our Next Generation Security Management platform by mapping threat prevention with management and control layer inside STP. We're going to talk about the threat prevention section in order to understand the role of each tab and section available in there. We're going to talk about the unified threat prevention policy and how we work with it. We're going to talk about the threat prevention policy layers. How does it work? Where the heck did we move my IPS settings and where do I find these, etc. We're going to talk about the threat prevention settings. How do I configure updates? Where do I set user check? Where is the protection history? And what is that? And so on. And whoops, what should I do if something goes wrong? And in this lesson, we're going to summarize everything with a hands-on lab. Do you remember STP? In this chapter, we're going to try to map threat prevention with the management and control layer in the software-defined protection architecture. The management layer in STP needs to be modular and support segregation of management duties to allow integration of security within the business. So with the ability to create dedicated threat prevention admins, the need for segregation of management duties inside the software-defined protection architecture can be met within our management solution. So why do I have a need for a dedicated threat prevention administrator? Well, software-defined protection is a pragmatic best practice approach to implement security for organizations. And this is also how we see that enterprises are structuring their business. So usually you have a network security team. They are managing the access control policy, the different firewall policies. They might be controlling application controls and URL filterings, etc. In addition to that, you will have an incident response team or a threat prevention team that is managing the threat prevention parts of the organization. They're managing antivirus, they're managing incident response, they're investigating bot infections, etc. And that part of the organization would like to have responsibility over the threat prevention policy components inside the security infrastructure. So let me introduce in Virtucon Industries number 2. That is Virtucon Industries Threat Prevention Administrator. So number 2's permissions have been segregated based on IT operational needs. So he's part of the IT operations team handling threat prevention policies and configuration items within the Virtucon Industries organization. So for the permission profiles for your security administrators, you can set the following permissions for your threat prevention admins. So you can allow them to view and read and write threat prevention policy rules, create policy exceptions, create profiles, work with protections, change the threat prevention engine settings, install the threat prevention policies, and do IPS updates. In this presentation, there are multiple slides hidden showing what the impact will be in the graphical user interface when setting each of these permissions and logging in as an administrator with the corresponding permissions activated. So in this case, if I would have the permissions to view policy rules, I would be able to view the threat prevention policy, but since I don't have permissions to view the access control policy rules, I will not be able to see the access control policy. So also as discussed, management needs a layered support to support segregation of management duties, while the control layer needs to provide flexibility in the deliverment of real-time protections to the enforcement modules. The unified threat prevention rule base allows to have multiple threat prevention profiles per gateway, where you can define protections per access profile, zone, VLAN, network group, etc. By layering the threat prevention rule base, you can build more granular threat prevention policies. We're going to talk more about this in the coming slides. This basically provides maximum flexibility in the protections being enforced at the enforcement modules to meet the high requirements seen in today's and future networks environments. So basically we can create one unified threat prevention policy, or for more flexibility, we can build a layered threat prevention policy. So that is how we map threat prevention with software-defined protection inside our security management solution. Now let's talk about the threat prevention section in order to understand the role of each tab and section available in there. So first of all the different gateway blades like IPS, antivirus, threat emulation, anti-bot, and now in later releases, threat extraction and so forth, are being unified into security policies and the threat prevention policy. Threat prevention have now been unified into one place, so it's going to be simpler to work with it, and it's also going to be more efficient for the security administrators to have all the different threat prevention blades configured within one place for the entire organization. Within the threat prevention policy, you have similar settings as you had in the access control policy. So in the top of this policy, you can, for example, click on actions. You're able to export the policy to, for example, comma-separated files for reporting. Some other parameters we have in here is, for example, the rule-based search. It's similar rule-based search to what we have in the access control policy. So it's smart, which means that you can do advanced searches like searching for a specific host or matching to a specific IPS protection, and it needs to be towards a specific destination, etc., in order to identify which rule would match that type of traffic. Policy apps are also available inside the threat prevention section, so it can give you more information about specific settings for each and every rule directly inside the policy. So you, for example, does not need to open and expand the protection profile. You can easily click on the rule and you get a summary of the blades being enabled in that profile, what's the performance impact those protections that are being enabled are having on your security gateway, which protections are being enabled based on confidence level, and so on. You can, of course, directly from here also view the different logs that are corresponding to different threat prevention incidents that we have identified that are related to the threat prevention policy. Directly from this log view, same way as you can do in the logs and monitoring view, you can right-click on a log entry and you can create an exception in order to exclude traffic from being inspected by those specific protections, or in general for all protections for that specific traffic flow. Let's move forward and briefly talk about the threat prevention policy and how we can work with it. So nowadays, threat prevention blades are unified into one policy, including the IPS blade, for more efficient workflow. The rule-based processing is done from top to bottom, so basically it works in the same way as it does in the access control policy. In R80, we can now assign zones to the protected scope or to the source and destination columns of the threat prevention security policy. Zones requires R80.1 gateways to be enforced, but this gives us the possibility to create threat prevention rules per VLAN on our security gateway, since a VLAN is being defined as an interface on the security gateway, and we can assign zones to that interface on that security gateway, and then we can assign that zone to the rule base of the threat prevention policy. Starting in R80, an exception can be configured on an entire threat prevention blade, for example, anti-bot, antivirus, threat emulation, or IPS. So this gives us the flexibility to evaluate new blades without impacting the entire organization. So I can, for example, have a test group where I activated the blade in prevent mode, and then I do an exception for that rule, saying that the entire organization is going to handle this new threat prevention blade in detect mode instead. Blade exception can improve performance if it meets the following conditions. So the exception's action when creating the exception for a specific blade is set to inactive, and there is no other exceptions about this exception rule with the action that's different than inactive. You can also, of course, create exception groups. This has been possible in the past as well. What's new in here is that you can assign the exception groups to automatically attach to rules where a specific protection profile is being used within the threat prevention policy. In Chapter 4, we're going to talk about layers inside the threat prevention policy. Basically how I work with it, and also what is this special IPS layer that is being automatically created under certain circumstances. So as mentioned earlier, R80 introduces a new policy concept called layers that will allow us to work more efficiently with the rule base and also structure it in a better way. Now, layers inside the threat prevention policy works a little bit different compared to layers inside the access control policy. In the access control policy, as you might remember, layers are matched in an ordered mode or in an inline mode. In threat prevention, we're using a matching mechanism called multi-match, where the traffic is matched against all rules inside all the layers at the same time. We're going to talk a little bit more about that later. In order to configure multiple layers inside the threat prevention policy, you right-click on the policy package and then you add your threat prevention layer for the threat prevention policy into that policy package. You can structure the rule base using the layers. For example, you can have different layers for different protection scopes. So you can have one layer for example, your e-commerce servers, another layer for your data center, and a third layer for your DM set. And then you can have separation of admin duties, allowing different administrators to work with different layers. Now, in current version, you cannot assign permissions per layer in the threat prevention layers compared to what you can do in access control. We can also allow gradual deployment of, for example, different threat prevention blades, allowing us to have specific layers for specific blades. If you have one layer for antivirus blade and the protections are set in detect only mode there, another layer for the entire organization as well as protected scope, but for the threat emulation blade, we might have the protection set into action prevent in there, and so forth. So let's look a little bit on how the packet flow within the threat prevention policy layers are working. So basically how I can find my way inside the main. Let's start on a small recap on how traffic matching was working in the threat prevention policy in pre-R80 gateways. We have our connection, and the traffic is being matched by the threat prevention matching engine, and traffic is being matched on a certain rule. So we're doing a top-to-down approach, and we're trying to find the first matched rule according to the protected scope, the source, the destination, the service, etc. Once we find a rule that is matching the traffic flow, we will apply the actions that are set for the protection profile for that certain rule. And then if we identify that some kind of packet in that flow is malicious, we're going to act upon that. For example, if the action is set to prevent, we're going to prevent the packet. If the action is set to detect but notify, we're going to detect the notified user, etc. Now, in R80, when using multiple layers, the traffic matching works in the following way. We have our connection, we have our TP matching engine. The traffic is being inspected in all the layers from a top-to-down approach at the same time. And in this case, the traffic could match multiple different rules inside multiple different layers, since those layers have the same kind of protection scope. So we have match on, for example, a specific source, we have match on a specific destination, specific service, etc. Once that happens, we're going to have a certain amount of rules where the traffic is matching with a certain amount of protection profile assigned to these rules. For example, in this case, 3 different rules. What we'll do then is that we will take an action on the traffic being matched in these three different rules. Depending on if we find something malicious in there, the action that we're going to take is going to be the most restrictive action, that is the combination of all these 3 different rules. So in the end, we're going to have a matched rule template that is a combination of all the protection profiles from all these 3 different rules, and the action that we're taking is going to be the most restrictive action. More details on how the matched rule templates are being created based on the protection profiles are going to be explained further once the R80.1 gateways are released and we do support installation of multiple threat prevention layers onto a security gateway. Where is my IPS settings inside the next generation security management server? In R80 and later, there is no more IPS tab. IPS has been unified into the threat prevention policy to allow more granularity with multiple different protection profiles per gateway. Because as you might remember, in the past we were only allowed to assign 1 IPS protection profile per gateway. So I couldn't set different IPS configurations for example, a group of servers, specific VLAN, and so on. With R80 and R80.1 gateway, we can define the IPS policy in the same way as we've been able to do with the threat prevention policy, where we can have specific rules for specific protection scopes assigned to specific protection profiles. When creating a new security gateway inside the management server that is of a version earlier than R80, so a R77.30 gateway for example, and enabling the IPS blade on this gateway, there is a new layer inside the threat prevention policy automatically created. This layer is a shared layer over all the different policy packages inside your security management server. And basically what this layer does is that it assigns the IPS blade only for the pre-R80 gateway. Because as you might remember, we could only have 1 protection profile for IPS per gateway in pre-R80. So this is for backward compatibility. So this is where you will find a list of all the different gateways that are pre-R80 running the IPS blade, and you can see the different protection profiles enabled for those gateways. Please also remember that the IPS policy for pre-R80 gateways are not installed when you're doing a threat prevention policy install. It is installed when you're doing an access control policy install. But when we upgrade to R80.1, IPS will be installed with threat prevention policy. So as mentioned earlier, you can set exceptions per blade. So for pre-R80 gateways, the IPS blade is automatically excluded in the unified threat prevention rule set if you're building such, and a dedicated IPS layer is created for pre-R80 gateways just to handle IPS configurations. As mentioned earlier, IPS policy is installed when installing the access control policy, and the administrator will receive notifications about this to ensure that they fully understand that you need to install the access control policy in order to apply the changes you did for your IPS settings on a pre-R80 gateway. In past, we had something called troubleshooting mode on the IPS profile. This has now been moved and is available under the gateway object instead. So similar to what we have with the threat prevention settings like the antivirus and threat emulation and so forth. If you want to switch the IPS on a pre-R80 gateway and also R80.1 gateways into troubleshooting mode, you now, instead of opening the profile, you open the gateway object and then you select activation mode detect only. This means that you will keep your settings on your protection profile, but the gateway will only act in detect only mode for those protections that are enabled for prevent. To retrain troubleshooting mode during an upgrade, the activation mode will of course be set to detect only if the profile that was assigned to the gateway was set into troubleshooting mode for the R77 gateway. What about those protocol violations that I have been seeing inside the graphical user interface? Protocol violations that we had inside the IPS settings for pre-R80 gateways in R77.30, for example, allowing you to configure parameters like SIM protection or, for example, HTTP protocol violation or, for example, aggressive aging. Those configuration parameters are not really a IPS feature, it's more a feature of the security gateway itself. So those configuration parameters has been moved away from the IPS settings and put into a place called inspection settings. So if you click on manage and settings, under the general tab you have the inspection settings. In there you can find different protocol violation configurations that you had earlier under the IPS tab. Now, to use these are protections that are protecting the gateway itself, ensuring that traffic are following the protocol standards, etc. These settings does not require you to use the IPS blade to be enabled on the gateway. So you can basically change these settings and then you do an install policy of the access control policy towards the gateway to enforce the new settings. Where are the geo protections? Those were also something that were available under IPS in the past. Now, geo protections have been moved to shared policies. So shared policies are shared over multiple different policy packages, meaning if I do a change inside the standard policy package for my geo protection, that change will also apply for my another policy packet under geo protection, because the geo protection policy is shared over multiple policy packages. But this is a place where you can find geo protection policies. So you can of course define your own geo protection policy, and you can then assign that specific geo protection policy towards a specific gateway. So you can have a specific geo protection policy per gateway, even though the policies are shared over multiple policy packages. Let's continue with talking about the threat prevention settings. How do I configure my threat prevention profiles with the different software security blades? How do I change the different engine settings for those blades? Where do I find these settings? And how do I configure my updates? Is it possible to revert my updates without breaking the access control policy, etc.? Under related tools, we have profiles when selecting threat prevention policy. The profile allows you to configure settings for IPS, anti-bot, antivirus, and threat emulation. In R80, inside the profile, we have a new feature to allow us to activate and deactivate protections for IPS based on their tagging, in addition to the activation policy inside the general settings of the profile. This is done to provide more granularity in the activation and deactivation of protections. So basically, all the different IPS protections are tagged with different tags inside Threat Cloud. This later allows me in the additional activation to enforce activation or deactivation of certain IPS protections according to the tag. So basically, in this example, we're activating all Modbus protocol protections as well as all protections that are tagged with the vendor Microsoft. In addition to this, we decided to deactivate all the protections that are tagged with the vendor Solaris, because in my organizations, for example, I might not be having any Solaris servers. So even though we might have some Solaris protections that would have been enabled by the general policy settings and activation policy, these would have been overridden with the additional activation settings, saying that all the Solaris tag protections should be set into deactive mode. Under updates inside the related tools, we have the possibilities to update, for example, our IPS protections. We have the schedule settings for anti-bot, antivirus, and we can ensure that the threat emulation has the latest images. Now, if you click on switch to version here, you have the possibilities to revert back to earlier IPS package versions, allowing us to revert back to a specific IPS protection version without impacting the rest of the configuration items inside the database. As you might remember in the past, people were using, for example, database revision control in R77 versions before they made an IPS update. So if something went wrong with IPS update, they reverted back the database using revision control. The problem with that was that they also then was reverting back the changes done on their firewall policy or application control and URL filtering policy and so on, since they reverted back the entire database. Inside R80, we have a much granular revision control where delta changes done inside the database. This allows us to revert back specific parts. So in this case, we have a dedicated IPS domain, and this is where we're storing all the different IPS updates, and they can then later decide to revert back to a specific IPS version of the protections and enforce that on our security gateways if something goes wrong. The threat prevention engine settings are available under the Manage and Settings, and then under threat prevention we can click on Advanced Settings and we can define how we want to have the fail mode working, what the action should be if the checkpoint threat cloud is not available, what are the anti-bot settings, etc. So those have been consolidated into one place under Manage and Settings. Whoops, what should I do when things goes wrong when working with the threat prevention policy? First of all, on opening a service request to Technical Assistance Center, you should always send a cpinfo file. But in addition to that, you can also collect the logs under cpm.elg and install_policy.elg. This contains information on what's going on while doing the threat prevention policy install or IPS policy install. If it's a problem with IPS update connectivity, you need to enable an additional debugging. So do a fw debug fwm, because we need to collect the fwm logs during the update. So collect the log file and send that into the service request. In this lesson we have 3 little evil labs. In the first lab, you're going to work with number 2, the dedicated threat prevention administrator, and try to see what kinds of permissions he has in the policy when you assign a dedicated threat prevention permission profile to that administrator. In the second lab, you will build a unified policy for the Verticon Industries organization, and then you will adjust the policy so that the threat emulation blade is enabled for the entire organization, but only in detect mode, while all other blades are still enabled in prevent mode. So it should still prevent traffic for IPS incidents, antivirus, and anti-bot incidents. But for traffic from internal zones, threat emulation should only be in detect mode, since currently Verticon Industries are evaluating threat emulation and they want to be sure that they're not making a policy mistake that is blocking legitimate traffic. In the third and last lab, you're going to search the log file for traffic being blocked by the inspection protections we talked about earlier. When you identify the traffic flows, you're going to create exceptions from the log entry for that inspection protection. And then you're going to try to locate where those exclusions have been created inside the policy for the inspection protections. Now, for more detailed instructions, you can download the lab guide available on Google Drive, same URL as before. Please remember that this is a lowercase l. Good luck.